Okay, so then question number 3 is the two corollaries is basically two shortcuts to finding all these distances within a right triangle that you've then used an altitude to divide into two other similar triangles. So let's go ahead and redraw this triangle. Nice big right triangle, we'll call that A, B. You always make the right angle C in right triangles. Okay, here's our altitude. Comes up from a right angle. We're going to call that, I'm going to use a different color. Now for the distances, we're going to call that H for height. This side here is across from angle B, so we call that B. This one over here is little a. This entire side over here is C. But then we also have these segmented pieces, and we're going to call the longer one here X, and this one Y. So there you go. Hopefully that's enough letters for you. But there's two shortcuts for how these sides relate proportionally. And again, I could show you using proportions where these formulas come from. We can talk privately if you want to do that, but I'm just going to show you the formulas, how to knock it out. So first of all is the relationship between the height and these X and Y, or the longer sides. And basically that the height is the geometric mean of these two sides, the X and the Y multiplied. So we're going to do this in a moment in question number 4, but if I know these two sides, I know that X times Y is proportional to, or is equal to, H squared. And that comes from, again, I'm not going to go into further. This is the second step of a proportion that used H as a common side. So, but if you just want to memorize it, the height, the altitude squared equals the two broken up pieces of the longer side of side C multiplied together. The other corollary is how to solve for A and B. Because notice, with this, I can find any of these three sides. If I know two of these, I can find the missing one. If I know X and Y, I can find H. If I know H and Y, I can find X. But then what about A and B? Well, they each have their own relationship. So B is the geometric mean of its included side. So B kind of corresponds with side X times the larger side, C. So C is this entire side. So C and X are the geometric mean there with B squared. And the same pattern holds for A squared. A squared is the geometric mean for its included side, Y. Notice A times, again, the entire side, C. So that way, if I know C and A, I can find Y. If I know Y and A, I can find C. Same thing, if I know B and X, I can find C, or any of those three. So between these three formulas, you can find knowing two sides here, you can find all the other sides of a right triangle and all the different pieces within it. So let's put that into practice here with question 5, page 512, number 12. And sorry, I've gone a little dyslexic here. 521. This is page 521, number 12. Because the two skills you mainly need to pull from 8.1 is, first of all, you got to be able to find the geometric mean. We did that already. So hopefully you can see that's not too difficult. The other skill is taking a triangle of this design and filling in the missing distances. So that's what this question is designed to practice before you get to your classwork. So, should have had this drawn already, but number 12 looks like this. Oops. Clean that up a little bit. I think drawing triangles was easier than this. Okay, and they give you distance Z, X, these are right angles. They tell you the altitude is 10. This piece here is 20. And this distance is Y. So notice it's exactly like that, but now you always have two. And once you have two variables, you will be able to, using these three relationships, find all of the other missing ones. Okay? So the question says we have to find X, y, and z. So the key is to look at it and say, okay, I've got the altitude and I've got the short leg. So first idea here is I can see there's the relationship between this and x, these two right here. Because again, h squared are the bottom two pieces multiplied. So I know that 20 times x is equal to the altitude squared. Okay, h squared, but in this case, 10 squared. Okay, don't let it throw you off that x was here and now they're calling this x. Think of it as the altitude, kind of the two roof pieces coming off the altitude, and then the one line that's broken into two pieces. The one line that's broken into two pieces, those multiplied equal the height squared. So x times 20 is 10 squared. So now we can just work through this. This will be the hardest part. If you can set it up and put numbers in the right place using these, then again, you just work through it with your arithmetic. So 20x is equal to 100. We divide by 20. So that means x is equal to 5. Yep. Okay, so x is equal to 5. And then you'll see once you begin to get those values, that's going to now free you up to find the other two now. So that might be one of the trickier parts, is looking at it and saying, okay, which one do I have enough information starting with to find my first variable? Then once you find your other first variable, that's a domino effect, we can now find z and y. So again, remember the other relationship. The first we just did is the height squared is equal to the longest side, or the big hypotenuse, its two pieces multiplied. So we just did that. 5 times 20 is equal to this squared. We also saw that this, what I'm calling like the rooftop sides that are divided by the altitude, that squared is equal to its corresponding short side times the entire long side. And now that we know this is 5, we now have the entire long side, so we're set up to find both z and then to also find y. So I can again say that z squared is equal to its short corresponding side, 5, times the entire side together. So that means 5 plus 20. So 5 times 25. So that gives us z squared equals 125. And so then now we just need to square root that. Okay, and so the square root, or so z, Mr. Trash Can, z is equal to the square root of 125. Now if you at least get to that, you're correct. Again, but we're like back at the situation here, the square root of 40, we'd want to simplify that, so let's practice it. A square root that goes into 125 is 25. This is basically 25 times 5. So that means that this is equivalent to square root of 25 times the square root of 5. We can simplify that. We know the square root of 25 is just 5. We can't simplify that any further. So z is equal to 5 square root 5. Okay? So that gives us this value right there. So that just leaves us to find y. Switch sides. I'm just trying to move around. And it's finding y is the same relationship as z. That y squared is equal to the corresponding short side, so in that case just 20, times the whole side together. So that is 20 times the entire side is 20 plus 5, so 25. And again, we'll work through that just like we did with the last one. Y squared equals, what is that, 500. Okay, and then we find the square root of 500. Sorry, that's getting small down there. Y equals the square root of 500. Again, basically the right answer, but we want to practice simplifying it. And again, if you're totally losing your mind, just get to this step, you're good. But you eventually want to practice simplifying that. So you think, what big square root goes into 500? Very good, Jocelyn. That's right. 100. So you could think of this as square root of 100 times the square root of 5. And you can take the square root of 100. You're going to leave the square root of 5 alone. Square root of 100, sorry, ran out of board space. That's 10 square root 5. So that means y here is 10 square root 5. And just check, make sure we did that correctly according to the book. Yes, we did. Yes, we can. Okay, so we found the 5 root 5, and 10 root 5. This is a typical problem. It's a little difficult. Work through it slowly. You've got an example here, then that's what your classwork for is to practice. You can Zoom me, and I'll work with you through a problem one-on-one. I've done that before, or you and a partner, work with both of you one-on-one through some of these. But just practice them because it's repetition. It's repetition. It's learning to recognize and implement these three relationships. The height squared equals the two pieces of the long side multiplied, and then the rooftop, as I'm now going to call them, this A and B here, this squared is its corresponding side times the entire side, and A is its corresponding piece times the entire side. And using those three relationships, you can find all the distances in a right triangle split up this way, as long as they'll always give you two to start with. Okay, good luck. Go. Don't have too much fun, but have a good time.